common denominator. We talked about divisibility. And then, I think we talked about division into cases. Oh no, we talked about floor and ceiling and division into cases. All right, don't worry about either of those. Okay, so just stick with those three, and I think you guys should be okay with everything. Okay, division into cases is just long, quite honestly, and I know it's a time sort of thing. And then floor and ceiling was probably the one that we did the least with. I'm not going to make you guys do that. Okay? All right. For indirect proof, there's only two types of indirect proofs, right, guys? The two types of indirect proof, just to remind you guys, was contradiction. Okay. And then contraposition. I won't tell you which of the two you have to use, okay? So, let me rephrase that. I most likely won't tell you which one of the two you have to use. So what I would do, guys, is I would start by trying contraposition because it's the easier of the two. And then if it doesn't work, then go to contradiction, okay? Because it's really easy to see if something would be easy to prove by contraposition. By contradiction, you actually have to work it out to figure it out for yourself, okay? So my suggestion is to try this one first, just because it's the easier of the two, okay? And that's the way I usually do it in real life anyway. And you'll be able to see it very easily if it does work. Okay. Now, if I specifically say prove by contradiction, then make sure you do it that way. Okay? All right, and then the only other question that you guys have to remember is the induction. Everybody's favorite. If you guys remember, there were three types of questions we worked with mathematical inductions. Okay, so inductions, remember we worked with the series or the sums. Okay. I think we did some divisibility problems. Okay, so make sure you guys go back through your divisibility stuff. And then finally, we talked about inequalities. So I'm going to give you guys one of each from each of those sets. Okay, so make sure you guys go back through, try to practice those types of problems. Okay, and by the way, after I outline everything, if you guys have some specific problems you want me to look at, that's fine. Okay, so if you guys are looking at the exam review, okay, like I said, you guys can cross out something like 12. Okay, so get rid of that guy because I'm not going to ask you guys to do division into cases. Okay, I wouldn't be that cruel. All right. I won't ask you guys to do something as nasty as 13C. That one's just not nice. Okay. The rest of those are fair game. Okay, so make sure you guys are okay with that. Okay. I would look back at the assignments in the exam. Okay, just to make sure that that's the caliber questions that you guys are okay with. These are just additional practice problems if you guys feel like you need more. Okay. All right. The next big section was what we just took the examination on. Okay, so that would be section 3. That's like your sets, your counting methods, and your sets, counting methods, binomial. So sets, counting, and binomial. Here. So, I will not put the procedural definition. So, for example, if you guys are looking at your exam review, something like number 15, where it says using only the procedural definition, where you have to use like the Boolean logic in tandem with that. Okay, I won't put that on there. Okay, so if you guys want to, you can cross that out. If you want to practice it, you're more than welcome to. Okay. But I think it would be fair for me to ask you guys to be able to prove something using set laws. Okay, so proof, using set laws. And once again, guys, just like with the Boolean algebra stuff, make sure you have that sheet that has a list of all the Boolean, or all the set laws on it. Okay, so make sure you have that sheet. Okay. If you need a copy of it, either go on Blackboard or email me. Okay. I might give you guys a set, or a couple sets in a universe, and I might ask you guys to do some operations on that set, like intersection, set difference, and all that stuff. So set operations, okay, and let me put in parentheses what I mean by that, like A intersect B, B minus A, universe minus B intersect A, something like that, okay? Make sure you guys go back through the examination, and I neglected to post the solutions, so I'll make sure I post those for you guys. But go back through those. If you didn't do too well in the exam, or go back through, I think it's assignment 8, that's where you guys can see those to kind of get a little bit of review for that stuff, okay? Most of you guys did really well with that on the examination, okay? But some of you guys did mess up a few of those, okay? I won't put like the isn't element of on there until it's like the subset of the set or something like that. That won't be on there. With the counting methods, you guys know what to expect with those. Okay, so with the counting methods, we talked about like being able to write the number of words or the arrangements that you get out of a specific other words. So like number of words from something like Mississippi. Okay. Or something like the number of words from like stapler or something like that. I'll get out of your way in a second, I'm sorry. I could give you guys like the jury problem, where I give you guys like a jury of 5 is to be constructed from of like 7 men, 8 women, or something like that. So make sure you guys go back through that. So I'll put this in here. Like the jury problem. Okay, and make sure you guys know like the counting methods as well as the probability stuff. Okay, so like I guess number of ways, as well as probability. I can't really think of anything else for counting methods that you guys would need. Okay, so like for instance, I think anything up there would be fair game that's on the exam review. So if I'm looking at like 17 or 18, I think both of those are fair game. Okay. By the way, if you guys have a question like during the examination about like what a set really means, like I actually had a number of people on the 3rd exam that didn't answer the question about hexadecimal because they didn't remember what hex was. Just come up and ask me, okay? I mean, that's something that I'd be happy to explain to remind you guys, all right? I don't want you guys losing like 3, 4, 5 points just because you can't remember the set that's involved. That's not my intention, okay? All right, the only other stuff I guess in section 3 would be the binomial theorem stuff. So make sure you guys go back through that. Okay. Well, actually, a couple of things. So, oh, we also had like the proofs of combination and permutation. So, make sure you guys go back. You can do a proof of a combination or a proof of a permutation. Some of you guys got really hurt on those problems. Okay, so like for instance, okay, number 19, okay, I think those will be very reflexive of what to expect to see on the examination. Okay, go back through, and of course guys, if you need some help with those, let me know so I can help you guys out with that. Okay. All right, and then the only other thing we had was the binomial theorem. Okay. think there were 3 questions from this one, so. So with the binomial theorem, make sure that you guys can expand. So like if I ask you to expand something like 2a minus 3b to the 4th, okay? Or if I asked you guys to be able to write something in closed form, okay? So like, write something like series k equals 0 to n of n combination k of 2 to the 2k minus 2n in the closed form. Make sure you guys do that. Okay. So I'll give you guys a moment to copy all that stuff down. Oh, I'll tell you guys when I'm done writing it out. So, everyone okay with what to expect? This section I think is going to have a lot of like little questions in it. So, and when I say a little question, it's like it won't take you guys as long as like one of these will, but it might have like 3 or 4 of them in there. Okay, so it might like each of the parts might be like 2.5 or 2 points each. So, very similar to what was on the examination. Okay. The only other section that's left is on the last 2 assignments, the new stuff. Okay, so that stuff hopefully isn't too bad for you all. The only thing that might give you guys some trouble is writing the general or the closed form for the recursive sequences, which we can certainly go over if you want to. Okay, so section 4. Okay, that's where you guys have your recursion and your graph theory. So recursion and graph theory. For the recursion stuff, something I might ask you guys to do is I might give you guys a sequence and you tell me the non-recursive form of that sequence. So it might be an arithmetic, it might be a geometric sequence. Okay? So I might ask you guys to write something like 3, -1, -5, -9 in the general form. And when we say general, that would be non-recursive. Or I might ask you guys to write something like, same thing, except geometric. So write something like 2,000, 1,500, 250, 125 in the same thing. Okay, non-recursive form. So hopefully those are pretty easy for you guys, okay? Also guys, make sure that you give me an initial value for these, okay? A lot of you guys on the assignment, you gave me the correct sequence, but you didn't tell me where n starts, okay? And I said it multiple times, it's just as important, if not more important, that you tell me where the sequence actually starts, okay? Otherwise it doesn't mean anything, okay? So you have to give the initial value. Right, that's why a lot of you guys ended up with like 19s, 18s, 17s on the last assignment, is because I didn't know where n started. Did n start at like 5,012 or did n start at 0? Okay, you got to tell me where it starts, otherwise it doesn't mean anything. Okay. All right, a question that you guys are definitely going to see is that I give you guys a recursive sequence. You guys tell me the general form or the non-recursive sequence. Okay, so. Write the general form. Okay. Something, and I'm not saying this is exactly what you guys will see, but something like a sub n equals 3a sub n minus 1 plus 2, or a sub naught is equal to 4. Okay. Or b sub n is equal to something like 1 plus b sub n minus 1, okay, where b sub n minus 1, or b sub 0, or actually we could do that plus, we'll make it more interesting, plus n squared, where b sub naught would be equal to something like 2. So, and that's the last few questions that were on assignment number 11. Okay, so most of you guys did really well with the last 2 of those. It was actually the first 2 where you guys didn't have to use those tables that some of you guys messed up on those. Okay, so make sure you guys go back through those and make sure you're good with that stuff. All right? And then there's going to be some graph theory questions on there. They'll be pretty simplistic. Okay, so like for instance, if I ask you guys for like the degree of a graph, or if I ask you for the edge set of a graph, or if I ask you for the vertex set of a graph, okay? There's literally a question on there that says, like, give me one of those, and I'll give you a graph, so you guys just literally tell me that, okay? I mean, that should be an easy 2 points for everybody.
Any isomorphic mapping?
No, there are not isomorphic mappings on there, okay? I might ask you guys to be able to construct a graph, if possible. Okay, so like for instance, I might ask you guys to construct like K5, or I might ask you guys to construct like K 3, 3, or I might ask you guys to construct a graph with 4 vertices of degree 3, 2, 1, 1, or I might ask you guys to construct a tree with 7 vertices, degrees, something like, and this is just approximate, 1, 2, 2, 2, 2,